Hello, so today we are doing this problem called letter combinations of a phone number, and the problem says we get a string digit for 2 to 9 inclusive. So we have only the numbers 2 to 9 in the string that we get, and we return all possible, we want to return all possible letter combinations that the number could represent. So a mapping of digits to letters, just like the telephone buttons, is given like this. So we get a mapping where 1 corresponds to nothing, 0 corresponds to nothing, 2 is ABC, 3 is DEF, just like the phone numbers basically, or phone buttons. So also a note here is that although these are lexicographical order, it doesn't matter, we can return them in any order. So pretty much, for example, for this string 2, 3, 2 can be A, so, and then can be B, and then can be C. And then each one of them has to be combined with the different combinations of 3, which are D, E, F. And so you can see AD, AE, AF, and then we combine BD, BE, BF, CD, CE, CF. Okay, so let's see how we can solve this. Problem. So I wrote the numbers here and the letter combinations that they match to, and so now let's see how can we solve the problem. So one thing is you can see is that we can have the string, let's say 23, and what we need to do is match each with a letter. So for example, for 2, that would be our first level, is the first number. We can match that to, it can be A, right? Or it can be, let me just draw this differently. So we can have 23 here, and it can go for A, and then B, and then that's for 2, and then C. So this here is just for 2. And then from that, we can put for each the matchings of 3, right? And so that would be D, E, F, right? Just one thing, I need to put the entire string so that you can see the last result. So we would have, first we would add D, so that would be AD, and then we would add E, that would be AE, and then we would add F, that would be AF. Same thing here, we would add D, and then we would add B, E, and then we would add F. And then same thing here, we would add C, D, C, E, and CF. And this is all through the value 3, right? And so you can see this tree will keep, if we had another number, each of these would branch off also to either 3 or 4, depending on the number of letters corresponding to that number. So immediately from this, we can see that we are using kind of a tree, where from one value it branches off to all the characters corresponding to the new number. And so automatically we should think about recursion or DFS, because we will be going down to get just one letter combination, we'll be going down like this. And then we will get that, that's why we get AD. For another letter combination, maybe we will go like this. So you can see it's DFS there. So we can solve this one with DFS. Now let's see what can our recursion or DFS recurse on. So again, we need to define our a couple of things here. So one is, what is the base case? And another one is, what is the recursion state, or reducing the state, how we are going to accomplish that. And sometimes we need to do special operations. And so what is the base case here is when the entire number is covered, which means basically that the number of letters match the number of the initial, the number of digits in the initial string, which means every digit got its corresponding letter. And so that here would mean that our base case here would be, so our case here would be if, so here what would be the state? It would be the index where we are in the current digit, right? Like, are we processing 2 now, or are we processing 3, or if there was another number, are we processing that number? And that would be the index. And the other one is the string we got so far. So here we have so far A, so that we can append D to it. Or maybe if we had something else, let's say maybe 5, then we would add G, so ADG. So we need this AD to append G to it. And so we need, let's call it a path. I'm going to call it a path. So if that path, the length of that path is equal to the length of digit, that means we are done, right? And done means just add the result, add the string or the path to the result, because that's a that's a complete combination. And so we would add the path, and we will be done. What is the recursion stage right now? So when we are at 23, let's pick a bigger number. Let's say we are at this. So what should happen is that we are here at this index, right, for example. And the path so far, let's say we have is AE. So at this point, we need to move the index, right, to the next position. And we need to add whatever letter that we had for 3, which here in this case, I'm going to add it, it would be E. And then in the next step, we'll move the index again to 5. And we would add whatever letter we picked for 4. Let's say we picked G. And so you get the idea. Every time we do index plus 1, and then we do path plus the string that we picked, right? And so, but for every one of them, you can see, like for B here, for 2 here, we picked A and we tried B and C. So for every one of them, for this one, try all characters for digits at index. Right? So here, that means that our recursion would be trying all characters in the mapping of that digit. So this would be our mapping here, where you could just pass a number as the key and get the characters. So the mapping of digits, which means just digits at index, which is the state of our recursion here. For every one of these, we are going to recurse, or let's call it DFS, we are going to recurse on increasing the index, which is what I said here. So index plus 1. And adding to the path is one of this character, right? So path plus C. So that would mean every time when we are moving, let's say from 2 to 3, we'll increase the index from 0 to 1, because that's the index of 3. And then we will try adding we'll try adding A and adding D, and then adding E, and then adding F to get all these 3. And then same thing here to get all these 3. And that's pretty much it. We don't need to do any operations because we are at the end. We are doing the path plus C in the parameter here. That's kind of our operation. Okay, so that's pretty much it for this DFS solution. And so let's code it up and see if it passes. Okay, so let's code the DFS solution that I just mentioned. So we need our DFS, and the state, as we said, is the index and the path. And the base case, which was checking if the length of the path is equal to the length of digits. In that case, we would have some result array here that will contain the results, and then we will append the path to that. And then we are done at that point. And we will recurse on all possible states, which are on all the possible branches, which are the mappings of the current digit, which is just digits index. And we will need to do DFS, which goes to the next number, index plus 1, and appends to the path this character and tries that. One thing we need to define is this mapping, which is just the mapping that I had from numbers to the character that they correspond to on telephone buttons, and I have it already here. And we need to just safeguard here if digit is empty, so that we can return an empty list. And now we get started at index 0, and the path starts out empty, right? That way we should do. And then at the end we can just return that result. So one thing I forgot to mention here is just the time complexity. And so you can see, as we did in the diagram or in the drawing earlier, it's we branch every time we branch with this DFS. We branch the number of characters in the mapping. So it may be 4, and sometimes it's it may be 4, but sometimes it's 3. And usually with these, that where you have recursion, the complexity is number of branches to the power of the depth of the tree that the recursion makes. And so in our case here, the number of branches can be at most 4, because we have at most 4 character mapping. Sometimes it's 3. So it's 4. Since this is big O notation, we need to pick the biggest one. And then what is the depth? The depth is the length of the digit string, because that's how many passes we will do, right? And so that would be basically, let's call it n. So you can see the time complexity is of 4 to the power of n. Now let's just run this, and in terms of space complexity, since we are using a stack and we are using this result, and the stack would be the number of branches again. Basically the stack, the recursion stack will use the same thing as the time complexity. So both the time complexity and space complexity would be all 4 to the power of n. So let's submit this and see if it passes. Okay, so it passes. So next, we've seen here how to implement it using DFS. Next, we will see how to implement it using BFS. Okay, now let's see how we can solve this problem using BFS. So for BFS, what we are going to change is that instead of processing this by DFS, this tree here of combinations, we are going to process it level by level, which means that first we will put in a current level list all the content of this level, and then for each one of them we will go through it and we will add one combination of the each character of the combination of the next number, until we obtain all the values of this level. And then same thing we'll do for the next level and the next level and the next level. So that's the main idea here. So how can that look like? So basically what we can do here is just have a current level string, have a current level list, that will start out with empty. That's our initial level, and then we will go through all the digits, and we will and then we'll prepare the next level. So we'll just create an array for that is empty. And now we will go through, for each digit we'll create a level that contains the previous level, and we append each combination of each combination of the letter, the new letter, basically the new digit, right? And so that would mean we will go here and check for every value in the current level. So let's call it x, and we'll append to that each combination of the value of the mapping of the current digit. So that would mean for C in mapping of the current digit, we will add to the next level the one value of the current level plus one of the characters. And so essentially what this will do is that we will take A as one of the values of the current level, and then we will take D as the digit of the mapping, one of the values of the mapping of 3, and then we'll append to that. So we will append to A D, right? Basically what will happen is that, for example, for the first case, we'll start out with an empty list, and then we'll go through the digit for 23. And so first we will have 2. We'll go through 2, and our next level gets to be empty first, right? And then we will go through every character in the current level, and now in the current level we have only empty, right? So we'll take that, and that would be our X. And now we'll go through every character for 2, every mapping for 2, which are just ABC. The mapping is ABC for 2. And so we'll go through A, B, C. So first we'll go through A, so that's our C. And now we'll add to next level A plus X plus A, which is empty string plus A. So next level would have A. And then after that we'll go and process the next character in this mapping. So this is we are at this for loop, so we'll process this B plus X plus B, so that's B, and then we'll do the same thing after that for C, and that would be X plus C, so that's just C. And now we will go again to this. So the current level is done, there's only one value, and now we will need, you will notice that if I just go here, I will override the next level. So I need to do something here. I need to say current level equal to next level. Why is that? Because at the next iteration I would want, in the next iteration here, I would want to go through in the current level the values that I just added, so I can append to them. And so what would happen in this case is that for the next iteration, my current level now is going to be, so this is current level, it's going to be the next level, which is ABC, and then I will initialize or reset my next level to be an empty list. And now I will go through the current level values. And so first, X is the first value of the current level, which is A. So I start out here for the current level. And so my X is going to be equal to A. And I will go through the mappings. Then I will go through this loop for the mapping of the value 3, which are D, E, F. So C, D, E, F, these are the values. So I start out at D, and I append to the next level X plus D, X plus C with the character, which is D here. So that would be A plus D. And so I will add to my next level AD, and then I will move again to the next character, which is E. And now I will add AE and do the same thing for F, right? And then once I did this, once I did this, I go again to the next iteration of my for loop, which now will take the value B. So now that one will be at B. And now my X value is B. And now what will happen is that I will keep adding to my next level. And so I will add, first I'm at first character, which is D, and so BD. And then I'm at the next character, BE and BF. And then I'll go to the next current level, C, and do the same thing. And you get the idea. Each time I increase the level. And so that's the BFS solution. And so you can see here that we did it with lists of next level and current level, right? There is a different way you can do it without needing two lists. And that's the usually what happens with BFS in general, even in like explicit graph. Here, our graph is kind of implicit, but even if you have an explicit graph with nodes and edges values, you can do it with this method where you have lists, but you can do it with another method where you have just a queue, a DQ in Python. And basically what will happen is that you can add to the back of the queue and remove from the front. And so that solution here, what will happen is that we will, so for that solution what will happen is that we'll still have the same mapping and everything, and we'll go through the digits in the same way, except here I need the index. But I will have a queue instead of a current level. So I would have a queue, which in Python would be a DQ that gets initialized to just an empty list with empty string, since that's the initial value. And what I will do instead is I will keep popping from the queue while I have an element of length I, which means it's from the previous level, which essentially would act as traversing the current level. And so that would mean I will do a while the length of the queue, sorry, the length of the front of the queue, which means in Python I can just get it with 0. It's equal to I. So basically this means that so when I'm traversing and I'm at level 2, let's say I'm at level 2, right? The previous level had values of length 1, right? Because those values would be A, let's say B, C, right? In my current level, I'm going to add values, let's say AD, BD, BC, DB, DC. And so I will keep adding to the queue. So here I will add to the queue AD, and so that would mean my queue would have, let's say I would extract first B, but my queue would have BC and then AD on the back, and then DB and DC and other values. And so what I want is to keep popping these values that are of length 1, because those are from the previous level and I want to add to them to make the new level, right? And the way that is preventing me from going over this barrier and taking this value from the current level, because if I add to that, well, that's not what we want in this problem. And so the way I'm limiting here is by checking that the length is equal to I, which is just the value of the previous level, because I starts from 0, right? And so that's the idea here. And after that, I will just do this. I will just pop the value here. So that would mean to get the X value here, which is corresponding to this, I will just do Q dot pop left to get the value at the end. And then I will do the same thing I'm doing here, which means for C in the mapping of digit. And now I'm storing the values not in a new array, I'm storing them in the queue. And so I can just append them here. And then at the end now, I would have popped all the values from the previous level, and I have all the values in the last level in the queue. And that's what we want. That's the list of combinations that we want. And so at the end, I can just return Q. Since Q is an instance of list, I will have the desired result. And so you can see these are the two methods of doing BFS. One of them is using toList, where we keep track of current level, we traverse it, and while we're traversing it, we append we add to next level, and then after that we replace current level with next level. Or we can have a queue basically where the current level is everything in the front or in the back, whichever one you want, and everything in the next level is on the other side of the current level. And basically the way we limit so that we don't go to the next level values is by checking that the length is equal to I. So that's essentially the idea. Now let's code these two up and submit them and see if they pass. Okay, so I have here the code for the first method of BFS. I don't think there's a need to write it from scratch because I already wrote it on the explanation, but this is just the current level, and we traverse the digit, we have the next level array, we traverse the current level, and we go through all the combinations of all the letters of the corresponding to that digit, and we add each of them to the one of the values of the current level, and we construct the next level, and then we make that next level be the current level so that we can process the level after that, and at the end we will have all the final values in the current level. And so that's pretty much it for the BFS solution using two lists. So let's submit. Okay, so that solution passes. Now to adjust this to the other method that I explained earlier, where we needed to, instead of using two lists, we are now using just one DQ that gets initialized to an empty list for, and then we would say import collections here. And after that, we don't need this next level since now we are storing everything in the list, in the queue, but we need to check to basically limit here to get only the current level values. And the way we are doing that is while the front of the queue has length I, which means it's kind of the current level. So this basically allows us to do this for loop of current level because we want to get only the current level values. So we stop when we reach the next level. And so that would mean this. We are going to get the X value, since this is what we want here, and that would be q.pop left. And from there, we do the same thing here, except now we are no longer adding to the next level list. We don't need it. Now we just add to the queue, and we return. We don't need to do this since the values are now in the queue, and we just return whatever is in the queue. Collections. Yep, it's not. It's like this. Yep, I didn't enumerate, so I should enumerate here to get the value I. Okay, let's submit. Okay, so this solution passes. Okay, so that's it for this problem. We solved it with DFS and then with BFS using two methods, where we used two lists and the other one we used a DQ. I think this idea, you should keep it in mind that BFS, it's usually easier to implement with two lists, but the canonical implementation is to use a queue. And here also you can see the graph is not explicit. We didn't have an explicit graph with the nodes and edges. Here we had an implicit graph where the neighbors were determined by this mapping here, right? And going through, basically with the mappings of the digits, and the neighbor is just the next digit in the string. And basically the neighbors are the letters representing the next digit in the string. So that's it for the solution. Thanks for watching and see you.